Welcome back to Lake Math. Now we're solving systems using elimination. Elimination means we're going to get rid of something. Main times we want to use elimination is when both equations have the same amount of either x's or y's. And again, just like the others, we can always use this so we can make our equation look like that. In this case, I've got same number of y's, same number of x's, but the signs on these are already different. And for them to be eliminated, I need them to cancel out. So I need the same number, opposite signs. Now, this equation, we can actually add equations because both sides are equal, right? That's what this equal means. Since both sides are equal, it's kind of like adding the same number to both sides. So I can add an entire equation to a whole other equation. So we add our x's. 3 minus 3, these are gone. They've been eliminated. Our equals comes down. And now, this is pretty easy. I just need to divide. Divide, divide. X is 8. Now, I've got x, I need to get y. So just like the other side, I'm going to have to take this and put it back in my equation. I pointed to the bottom equation because it has positive y. It's going to be easier for me. So 4, and then I'm going to use parentheses. So instead of x, I put 8. We're going to multiply these out. I'll subtract. Subtract. My y comes down. My equals comes down. 35 minus 32 is 3. And now I divide. So y is 1. And now I've got 2, so I need coordinates. So 8, 1. All right, now on this one, I've got 3 and 4 for the x's, and then 5 and 10 for my b's. I think I meant to change them to y's, but I didn't. Sorry. Now, what I can do, this, if I multiplied this by 2, it would be 10. But I need the opposite sign. So I'm going to multiply the whole top by negative 2. Now what that's going to do is make this the same number in the opposite sign. Now I'm going to do this all the way through. And when I write this stuff down, I'm just going to write it down underneath. So 2, 3, negative 6, negative 2 and 5, negative 10, negative 2 and 27, 54. Now I'm going to add the entire top equation to the entire bottom equation. So these, I'm going to get negative 2x. These are gone. And this is 8. And then I divide. Divide. Whoops, I forgot the negative. Negative 4. Now that I've got my x, I need to go back and get the b. This first equation is probably easier, so I'll use that one. And I'm just going to put this where the x was. And multiply these out. So I get negative 12 plus 5b, negative 27. I'm going to add to get my numbers on the other side. So 5b, negative 15, and then divide. Divide. B is negative 3. And now I need to put these together. So negative 4, negative 3. And we can always make it look like elimination if we need to. I gave myself a spare page to work, but didn't need it. Alright, this one's a little uglier. These aren't multiples of each other. These aren't multiples of each other. So I'm going to do the y's. I'm going to multiply the entire bottom by 3. I got it by looking at that guy. Just like a common denominator on fractions, sometimes you need to multiply both. I want to multiply the entire top by that guy. They already have an opposite sign, so I don't need to do that. So I'll multiply this through. And now I'm going to multiply this through. So 3 and 5, 15. 3 and 2, 6. 3 and 3, 9. Now my y's are the same, so these are going to cancel. So I'm going to add the entire top equation to the entire bottom equation. So these give me 31. These are gone. My equals comes down. And negative 31. If I divide, 31 divided by 31, x is negative 1. So I got x, now I need y. I'm going to use this equation because in this one, it's just 2y and it's positive, so it's going to be easier. Remember, use parentheses. I just put this where the x was. I multiply these two. And now I need to get my numbers on the other side, so I'll add and add. My 2y comes down, and 5 minus 3 is 2. I divide, y is 1. And now I've got a coordinate, so I need to put it together. Negative 1 and 1. Alright.